Hello! In this video I'll show you how to use LS-DYNA and some of its features. The version I will be using in this demonstration is version 1.0 with a build date of March the 1st, 2018. LS-DYNA is a program used for easily starting and administrating LS-DYNA simulations. It also contains features to set up and monitor the current usage of the LS-DYNA licenses. LS-DYNA is a licensed software from LS-TC, and in order to run LS-DYNA you need to purchase a license from your LS-DYNA distributor. We start by looking how the license for LS-DYNA is specified. So we go into the license settings in the main menu. Now there are basically two scenarios. Either you have an existing LS-DYNA license server on your network, and in that case you just have to enter the host name for that computer in the field for the server host name. And press enter. The license info tab will show if you can access the license server and also the number of in-use and free licenses. The jobs tab will show you the currently running jobs and the amount of licenses in use for each job. The second scenario is that you don't have an LS-DYNA license on your network and you want to install it. The license server for LS-DYNA will be locked to the hardware of one computer. This computer must be able to communicate freely with the other computers that will run LS-DYNA. So now say that you want to install the license service on the computer that you are sitting by right now. So to do so, go into the Request License tab and you will see the Request License wizard. First you have to confirm that you want to install the license service on the computer where LS-DYNA is currently running on. Second, you have to confirm that the license server computer and the other computers that will be running LS-DYNA can initiate contact with each other over the network. In the last step in the wizard, you have to specify one or several IP ranges. The IP addresses within the specified ranges will be granted licenses from the server when requested. And if the IP of the client is outside the specified ranges, the license request will be denied by the server. So it's important to set this to match your network settings. Next, click Save to save the LS-TC server info file. I can save it to my desktop. And this is the file that you have to send to your LS-DYNA distributor to obtain the license file. Once you receive the license file back from your distributor, you install it in the Administrate License tab. Click on the Install button and select the license file. The installation is automatically requesting administration privileges in order to install the license as a Microsoft service so that it is automatically started if you reboot the computer. After this, the license server is installed and running. A license server is now running on my local machine, and I can change the server host name to localhost to now see the number of free licenses running on this machine. And if accessing this machine from another computer, you have to type in the host name for this computer, which in my case is Forpus. We can use that as a license server name as well. LS-DYNA is a command-based program, meaning that it's always started by executing a command with appropriate command line arguments. And LS-DYNA will help you to create this command by using a parameterized way to define an expression for the command line that starts LS-DYNA. The four parameters at the top, input, solver, end CPU, and memory are the four most common arguments to LS-DYNA. These parameters are made to be easily modified in the interface, and the input file can be dragged and dropped onto the main window or to the program icon shortcut on your desktop. And then to demonstrate this, I can extract the example models from LS-DYNA Win Suite. So if I go into Help and Extract Models, just check out the examples, put them on the desktop. Open up the examples directory, take the first one, and we can take the keyword file and drop it anywhere on the LS-run main window, and it's inserted here. The other way around, if LS-run is not up and running, you can drag it onto the desktop icon, and it's inserted and LS-run is automatically started. The memory parameter is usually needed to make LS-DYNA allocate enough memory before the simulation begins. And it may be difficult to know how much memory that will be needed for LS-DYNA to run the simulation. So for this reason, there is a feature up here that will try to estimate how much memory will be needed for the currently selected model. So I recommend it to keep this on and let LS-run estimate the amount of memory. And if for some reason it fails to set a suitable value, you can turn this feature off and enter whatever value you want. But for now we can keep this automatic estimation tool on. LS-DYNA comes in an SMP version and an MPP version, and each one of these comes in a single and a double precision version. So we basically have 4 versions of LS-DYNA for every release of LS-DYNA. So the version you want to use will be depending on the problem that you're going to analyze. And to switch between the different solvers, you can select the preset feature. And each of these presets holds a combination of both the solver and the expression. So if we change, well, look at the expression here, it says just solver, which means that we just execute the SMP version of the LS-DYNA. Switching to MPP single precision will change the solver to the MPP single, and the expression for executing LS-DYNA will be slightly different because it will be starting with BI-exec instead. So for SMP single, if you want to use another version of LS-DYNA, say revision 9.2, we can open up the solver directory and select SMP single for this version and open. It will be inserted, and now we can update the preset for the SMP single option by pressing the set button. So now the next time we switch to MPP single, we see that, and back to SMP single, it will be the 9.2 version that will be used for this preset. If we look into the action bar in LS-run, you will see that they are grouped in 3 different sections. The first section here are settings that you can do before the analysis is started. The second group is the so-called sense switches that you can send to a currently running analysis in LS-DYNA. And the last group are actions that you can take after a simulation has been done. If we now want to run the example model in the SMP version of LS-DYNA and run it on our local machine, we just have to press the play button and the job will be added to the job table. And the job command can be inspected by right-clicking in this cell, and the first line is the full command line. And there are also lots of other parameters associated with each job, so you can right-click on the menu and choose to add another property to the table. So if I add the NCPU parameter, you'll see that it's set to 1 because the NCPU was set to 1 in the expression. So now we can stop the job by sending the stop sense switch to the job, and you'll see the progress in this status field, and clicking there will stop the job. Now we can increase the number of processes for the job, and we select to run it on 4 threads and start the job again. LS-run will now detect that there are results files in the directory and ask if we want to delete those, and I click yes. The previous results files are deleted, and then the simulation is started. And the progress can be monitored in the status field, and LS-DYNA process is now running in the background, so we can choose to close down LS-run, and when we restart it, the progress and all the jobs will be resumed and automatically be picked up. This will give the estimation of how long it will take for the job to finish. And now say that we want to stack up a number of jobs during the night, and we only have 4 cores in our computer and maybe 4 licenses as well. So we don't want to start all the job at the same time. We want to run them in sequence. We have an option to do that if you go into the settings and set the maximum number of simultaneously running processes to 4. And let's start up this job again. Clean the previous results, start the job, and we go in and create a parallel folder to this. We do a copy of it, call it test 2, and delete the results files that have been created, that file as well maybe. And now say that you want to run this file, and we add the bumper impact test 2 to the job table. We now see that because there is a currently running job with 4 processes, and we have set the maximum number of running processes cannot be more than 4, the currently last added job will be waiting in a local queue on your machine until job number 3 is finished. So we'll see now when the job is finished, job number 4 will automatically be started. So in this way you can stack up how many jobs you like during the night, and they will be run in sequence. When the job has finished, you can open up the D3 plot file in ls prepost by clicking the prepost button, and you can inspect the results as usual. Similar, you can open up the text files that are generated by LS-DYNA. So if we want to open up the message file, click the text editor button, and it will be opened up in the text editor that you have associated with the txt file. You can change what editor to use in the settings up here, and you can also change the version of ls prepost you want to use. Now say that we have made some changes to the input file of this job and want to rerun it again. We just have to select the job in the list and click the rerun button, and in the same way as before, it detects the existing results file and asks you to delete it. And now the job is running again. The trash can icon will just remove jobs from the job table below. So if I select a job and press the trash can, the jobs are deleted. If I choose to select the trash can for this job, the analysis will still be running. It will only be removed from the job table, but it will not kill the process. Now when running the job on my local machine, I run it on my laptop, which is not particularly fast. So if I want to run the same model on a remote computer, I have another which is faster, which is a Linux machine, and I can select to run it on this remote machine by using an SSH connection. So the remote machine have to have an SSH server, and you have to be able to log into that computer with an account. And the preferred way is to use an SSH agent to store your passphrase for your login credentials. So on Windows here, I can start up Pagent. Let's see here if, yeah, there it is. And view keys. I don't have any key added, so I can add a key. Open that file and enter my passphrase. Yeah, and now in the settings for the remote option here, you will see the remote host execution and the small frame around these 4 lines. You have to specify the host name for the remote computer, which is Hazel in my case, and my username. I could use an SSH key file which have a passphrase to it, and use the interactive running the job in the command prompt and type in the password to execute the command. But now that I use Pagent as the storekeeping for the login credentials, I don't have to use the key identifier. And the file system looks a bit different on the Linux and the Windows machine. Currently the input file is put in the C:, and this is my local disk, and it is of course not accessible from Hazel, the remote machine. So the file has to be put in a location where it's accessible from both machines. So if I temporarily close that and open up the file browser and go into a file share and open up a directory where I have an input file, the same input file but on a shared disk. This path is not accessible from the Linux machine because it starts with a Z:, but it's accessible here from the Windows machine, so I have to set up the mapping of Z:, to what it's on the Linux side, and I know it's mounted as in the /disk folder, and I press enter. And the solver cannot be the Windows executable on my local disk, so I have to change that as well. So I changed it to just LS-DYNA, which is an alias on the Linux machine. And as you see here, on the preview for which the command to be executed, it's LS-DYNA and I equals to, and then the correct path to the Linux file on the other side. So now if I press enter and add the job into the job table, it will wait for LS-DYNA to start on the remote site, and now the job is running on my remote Linux machine. And it's running considerably faster. So this is a good way to execute command from your local Windows machine onto a Linux machine. The third way to start LS-DYNA simulations is to submit it to a Windows HPC cluster. So if we change to that and take a look in the online manual and go to the section where it's written about the Windows HPC submission, you will see that there are some requirements in order to submit to Windows HPC. So you have to be a registered user on the HPC cluster, which is taking care of your cluster administrator, and the client utilities is part of the Microsoft HPC pack, and this must be installed on your client machine where you are going to submit the jobs from. And it's quite important to use the same version of the HPC pack that is used on your HPC cluster. I have noticed some incompatibility issues between different versions of HPC pack. And you also have to store the credentials for submitting job to the cluster, and that can be done. It seems to be a run once. So if you start at the command prompt and run this command and replace the my domain, my username with your domain and your username, and similar with the head node, you replace the my HPC server with the name of your head node computer in the cluster. The input file and the solver has to be accessible on the compute nodes on the cluster. This typically means that both the input file and the solver needs to be placed in the location which is accessible on a file server from both the local client machine and the compute node. And also make sure that the head node for the cluster is specified in the ls-run settings. Okay, so we take a look in the settings. Here at the bottom we have the Windows HPC, and the head node name is in my case automatically filled in, and it will probably be in your case as well if you have an HPC cluster. And there's a job template file which will be used for submitting the job using one of the programs that comes with a Windows HPC pack called job. So this file is a template that will probably work in your case, but you're free to change it and modify it if you want to, of course. So everything seems to be fine here. So if we take a look on the input and the solver, we see that this is on a file share, but it's not on a location which will be accessible from the compute node. Also the solver is on a local disk here, so we have to change. We can start with the input file and go to the file share which is available both from my client and the compute node. We go into my directory and select the input file. You see the UNC path will pop up, and similar for the solver, we go into the same file server and go into and select the SMP version of let's see here, there. Okay, so now we have set the SMP single version for 10.1 on the Newton disk, and we can now update the preset for the SMP single by clicking the set, and now it's set for the preset is set for the Windows HPC. So if we just check and go back to the local option, you'll see that the solver is changed back to the executable on your local disk. And going back to the Windows HPC, we'll see that the solver, the preset solver for SMP single is set to the file share accessible on the Newton head node. So now we add the job to the queue here, and the job is now running and has been started on the cluster. So if we check to the right of the job table, we have another tab called Win HPC Usage, and we see this table with the jobs that currently are running on the clusters that you have. So the jobs will, all jobs on the cluster will be present in this list if the state is either running or in queue. So we see that the Newton cluster have 40 cores and 4 cores are occupied, and there are 0 cores waiting in the queues. Yeah, and now the simulation is finished, and as we see here in the Windows HPC usage table, there are now currently jobs running. So yeah, that was it for this tutorial, and hope you liked the presentation. Goodbye.